All right, class. So I decided to make this extra bonus YouTube video for you guys about the difference quotient. On our first quiz, the first problem was to solve a difference quotient, and it is the problem that the majority of you had the most difficulty with. So I'm going to work through 3 more examples to hopefully clarify some things. Now, the difference quotient is something that's primarily used in calculus, right? For now, what I want you to do is focus on it for variable manipulation. So if I'm given a function and I have the outputs of my function x and x plus h, as long as h doesn't equal 0, right? Because then x would be equal to x. The difference quotient, okay, which is the rate of change, would be the change in y over the change in x. So you're going to solve for f of x plus h minus f of x over h, okay? And we use this in calculus to find the limit and the derivative and all those good things. But for now, it's variable manipulation. So let's take a look at our first example. I have f of x equals negative x minus 2. So I'm going to take f of x plus h minus f of x, right? That's my change in outputs, my change in y, over h. The only difference is I don't know what h is, and that's okay. It's a real number, so life's good. So I'm going to substitute in x plus h for x. So I have negative x plus h minus 2 minus f of x, which is negative x minus 2 all over h. That gives me negative x minus h minus 2 plus x plus 2 all over h. So I get that negative h over h equals negative 1. Notice how that's the slope, right? This is a linear equation with a slope of negative 1, right? So this gives us the rate of change. Now, sometimes when we solve for the rate of change, we'll have h left over, and that's okay. Let's work through an example where that is the case. So I have f of x equals 2x squared plus x minus 1, right? This is a quadratic formula. Its graph looks like a parabola, and its rate of change is not constant, right? Parabolas are shaped like this, so my rate goes from decreasing at faster and faster rates to increasing. So I'm going to take f of x plus h minus f of x over h, and then again, it's just variable manipulation. I'm plugging in x plus h for x. So I have 2x plus h squared plus x plus h minus 1 equals, I don't know why I did an equals, minus 1 minus 2x squared plus x minus 1. That's going to give me, remember that I have to FOIL this out. I can't just distribute that negative. So I have 2x squared plus 2hx plus h squared plus x plus h minus 1, all of that minus 2x squared minus x minus 1 over h. Okay, let me rewrite that because that's pretty messy. I'm sorry. So I'll go ahead and distribute this. I've got 2x squared plus 4hx plus 2h squared plus x plus h minus 1 minus 2x squared minus x minus 1 over h, right? That's why we got to think of this as variable manipulation. Some things are going to cancel, and that's really cool. Let's take a look at what cancels. So I have positive 2x minus 2x, canceled. I have positive x minus x, also canceled. I have negative 1, that becomes a positive 1 because you have to distribute the negative. That's going to cancel. So I'm left with 2h squared plus 4hx plus h over h, and I'm going to pull out a factor of h, so I get 2h times 2h plus 4x plus 1 all over h, and my h's cancel. So I'm left with the difference quotient of 2h plus 4x plus 1. Okay, one more example and then I think we're good to go. Now I have f of x equals 1 over x. This is the reciprocal function. So let's take a look. I've got f of x plus h minus f of x over h. That's the key, and then it's all variable manipulation. So I have 1 over x plus h minus 1 over x. And remember, when I am adding or subtracting fractions, they have to have the same denominator. So I'm going to go ahead and multiply my first function by x over x and my second function by x plus h over x plus h. So that way we can have the same denominator. So I have x minus x plus h over x times x plus h. So much division going on. That gives me x minus x minus h, because we distribute that negative, over x times x plus h. Let's rewrite this instead of divided by h, divided by 1 over h. We're pulling out that fraction. So I have negative h, because my x's cancel, over x plus h. Well, when we're dividing by a fraction, that's really multiplying by the reciprocal. The reciprocal of 1 over h is h, so I've got h. My h's cancel, so my difference quotient is 1 over x times x plus h. So there are 3 more different quotients examples. I hope that clarifies some things for you all, and I'll see you in class.